Now mutual inductance. Mutual inductance kita implement in a transformer. Okay. So for mutual inductance, we have two neighboring coils. We have two coils close together, close to each other. Okay. So untuk coil 1, kita ada coil is connected to the AC so that the current will be flows in the circuit. So bila current flows, there will be sama ada the current increase or decrease, so there will be a change in the magnetic flux through surround the coil 1. So magnetic field lines daripada coil yang pertama ni dia akan kena pada coil yang kedua sebab coil yang kedua ni position dia close to the coil 1. So nampak tak garis-garis medan ni dia passing through the coil 2. Alright. So the changing of the magnetic flux from the coil 1 will induce the EMF in the coil 2. So EMF induce the coil 2 asalnya disebabkan oleh adanya perubahan current ataupun perubahan magnetic flux daripada coil 1 that passing through the coil 2. Okay. The changing current in the primary coil, so coil 1, primary coil lah, creates a changing magnetic flux through the secondary coil, primary and secondary, which leads to an induced EMF in the secondary coil. This effect is called mutual inductance. Okay, changing magnetic field lines were produced by primary coil, had induced EMF current in secondary neighboring coil. The circuits of coil 1 and coil 2 that has number of turns N1 and N2, dia share the same amount of inductance. Nilai inductance dia sama. So that's why kita panggil dia sebagai mutual inductance. Mutual inductance for coil 1 dengan coil 2 dia sama ni. Dia punya formula pun sama. Right. So mutual inductance in coil 2 is equals to number of turns in coil 2 multiply with flux. Okay. Then changing of magnetic flux from the coil 1 divided by I1. Okay, asalnya diambil daripada EMF induced in coil 2 adalah bersamaan dengan negative inductance. So M ni inductance. Cuma untuk mutual inductance ni sebab ada dua coil berhampiran, so dipanggil mutual inductance M. Okay, so nilai EMF in the secondary coil dia bergantung kepada rate of change of current in primary coil. Okay, then dia terbalik. The EMF induced in primary coil is directly proportional to the change of current in coil, secondary coil. Alright, so the formula dia sama. SI unit for inductance is Henry. So dia sama macam inductance. Okay, so at the end, macam mana dia derive ni uniform module So mutual inductance for both coil deliver the same formula, which is mu naught N1 and 2A over L. Okay. Normally iron core is inserted between these two coils. Sebenarnya dia nak increase the magnetic flux through both solenoid. Okay. That way, energy from coil 1 can be transferred to coil 2. Kita tengok contoh. Two coils are placed close to each other where the current in the first coil, so primary coil dia, decrease at the rate of, so dia decrease, maknanya di over dt, di1 over dt dia decrease 1.1. Okay, mutual inductance between the coil is 0.5 Henry. So yang ni M. Calculate the induced EMF. So dia nak EMF generated in the second coil. So induced EMF in secondary coil is equals to negative M di1 over dt. So negative, letak je negative M 0.5 di over dt tadi yang ini 1.1 lah, letak negatif sebab dia kata decrease. At the end, the induced EMF in secondary coil is 0.55 volt. Okay, now we go to the energy stored in inductor. The battery has to do work to produce a current. The work is separated as energy stored by the inductor. So the EMF induced in RL. So kita ada resistor dengan inductor dalam circuit ni. So the EMF induced in the inductor oppose the EMF of the battery. Okay, so by using Kirchhoff rules, loop rules, sebenarnya kita ada sebenarnya yang ambil sum of voltage sum. So voltage of the battery sama dengan voltage of the resistor. Ini okay, darab dengan EMF induced di inductor. L di over dt. Okay, then dia nak tunjuk ni macam mana at the end dia derive energy stored in the inductor. So daripada Kirchhoff loop rules ni, dia darab dengan I untuk left hand side dengan right hand side. Okay, daripada equation yang pertama dalam petak kuning ni, dia darab, dia multiply both side with I. Sebab apa? Sebab dia nak dapatkan power, rate of energy. I, V, dia dapat power. Rate of energy. Okay. So dia darab dengan current, apa kita dapat? So the term EMF darab dengan current yang ni dekat left hand side ni adalah rate of at which the battery delivers energy to the circuit. So yang ni adalah rate of energy from the EMF ni, yang daripada power supply ni. Okay, the terms I square darab dengan R ni adalah energy dissipated by resistor, ataupun dipanggil thermal energy ataupun heat energy lah. Heat energy dissipated by the resistor. Yang ini sebutan yang ini. Okay, so at the end kita akan dapat rate of energy stored in the inductor. Yang ini rate of energy, rate of energy. Tapi sekarang ni maknanya kalau kita bagi sebutan tu dia adalah du over dt, rate of energy. Tapi kita nak u sahaja. So macam mana nak hilangkan t ni? You kena integrate. Alright, so sekarang ni daripada rate of energy stored in the inductor, kita nak dapat energy stored in the inductor. Kita tak nak rate tu, so nak buang dt. Daripada Li di over dt, you kena integrate. You do the integration. Li, okay, then you dapat macam ni lah. Dan ni step dia. So Li square over 2. So yang berubah adalah current daripada kosong sampai certain value of current. So at the end you will get the energy stored in inductor is equals to half Li square. Tengok contoh. A current 2.5 ampere flows through a coil X. So yang ni adalah Ix, producing a total magnetic flux of 0.6 Weber in the coil. So yang ni flux X. If a coil Y is brought near coil X, a total magnetic flux of 0.215 Weber is produced in coil Y. So yang ni magnetic flux Y. Now calculate the self-inductance of coil X. So self-inductance sama dengan N flux over I. So yang ni Nx flux X Ix. So Nx ada ke? Tak ada. Yang ni a coil. So N dia sama dengan 1 lah. Okay, flux dia dah cakap dah. Flux X adalah 0.6 bagi dengan Ix 2.5. Then you will get self-inductance in X coil adalah 0.24 Henry. Okay, then find the energy stored in coil X before coil Y brought near to it. Alright, so dia nak tahu energy stored in that inductor lah. So half Lx I square. So Lx daripada atas, current dia dah bagi dah Ix ni yang kita cari ni, yang kita ambil daripada soalan. So you will get 0.75 joule. Okay, B, calculate the mutual inductance of coil X with coil Y. So mutual inductance XY sama dengan, tak kira lah kalau you ambil, sekarang ni dua-dua kita, current, okay. Yang ini ni sebab kita tahu current daripada X. So kita boleh calculate lah. Flux Y sebab dia punya formula M2 sama dengan flux 2 over I1. Ataupun kalau nak terbalik, mutual inductance ni dia punya value dia mesti sama. M1 mesti sama dengan M2. Value dia sama. So kalau nak ambil M1, dia jadi flux 1 over I2. Value M1 dengan M2 ni mesti sama. So kita ambil yang atas ni. So dekat 2 tu 0.215 over 2.5. So dia dapat 0.086 Henry. Alright. If the current in coil X is reduced uniformly from, so dia bagi dah changing of current. So yang ni I initial, this is I final. In time of, so dia bagi dalam time interval dia, dia dah bagi dah dt dia berapa. What is the induced EMF of coil Y? Alright, so kita guna formula ni. Flux kedua sama dengan negatif M daripada B tu. Alright, so rate of change of current. Yang ni lah. Final tolak dengan initial. So you will get the value of voltage.